Number 15 is regression. And what's a regression? Well, a regression means you're going to collect data in two variables, x and y. And based on putting that data into the calculator, or using a formula for that matter, we get so used to calculators, this used to be done by hand, you create a regression equation. Now, based on this indicator called the correlation coefficient, which is abbreviated with the letter R, it tells us how good our equation, our regression equation, represents our data. Now, if you had taken a statistics class, they'll probably ask you which is the best regression equation to use, whether it be linear or quadratic or cubic or logarithmic or exponential or power. Which one is best? Now, this particular question, it's most likely to ask you to do a specific regression. They asked you to do a power regression. So after I put the data into the calculator, you might be wondering why I have this x equals 1, x equals 2, x equals 3 there. Because the question indicated that the year 2000 was represented by x equals 1. So you have to put this data into the calculator, not the 4-digit year. In fact, you'd probably get something called an overflow error on your calculator if you tried to do it, because the calculator can't handle it. Put the data in the year as x is 1 is 2000, x is 2 is 2001, x is 3 is 2002, etc. And if I'm going to evaluate the regression equation by year, I have to put it in as this converted year, because that's how the equation represents the data. So after I put this into stat edit and identify that in L1 I'm putting my year since 2000 is x is 1, and in L2 I'm putting my new cases in, which is y, I go to my stat calc and I do a number A, which is a power regression. It tells me that it wants me to round the coefficients to the nearest thousandth. That's 3 decimal positions. So after I do the calculation, I write down what's on the calculator screen. Look how I wrote down the little template that they give me for a power regression. Full screen for the A and the B. I write down R even though it wasn't necessary because I wanted to talk about it. You can see that this is really close to negative 0.97. So this data is going to decrease, but it's going to be pretty good data because it's close to negative 1. And since the correlation coefficient is in between negative 1 and 1, the closer it is to negative 1 or the closer it is to 1, the better the data is represented by the regression equation. So, now I round these to the nearest thousandth. That's my A. Here's my X. You don't have to put a caret there, but this isn't an exponent. Putting the caret there, it assures it. And this is my B. So that is the regression equation. Next, they ask me to actually use it. So they want to know how many new cases will be in 2007. Well, I can't put 2007 here because my data has been converted. So 2007 really means x is equal to 8. I show this. I type my calculator. They say to the nearest whole number. That's the nearest whole number, which is also the nearest integer in this case, because this is positive. And since that's not bigger than 5, I get 272 new cases. Now, number 16 was all about that correlation coefficient I've been talking about, seeing that it's from negative 1 to 1, knowing that the closer it is to negative 1, it's going to be better, stronger, stronger negative, and the closer it is to 1 is going to be a stronger positive correlation. This is a line. If you put this in the calculator, you'd see it increases. I hope that you know that without putting in the calculator, but if you don't, it's okay. This is a slope. Since it's positive, the line is going to increase. Therefore, the correlation coefficient has to be on this side. It has to be positive. That's why it's choice 1. Remember to turn on your stat diagnostic if you're doing a stat calc, if you want to see your correlation coefficient. You find your stat diagnostic in mode on the second page.